I work at QuickBase as a staff DevOps engineer, and I also am president of a Mass Cyber Corporation. Let's real quick with some housekeeping. Disclaimer, my opinions expressed are mine and mine alone, and not necessarily those of any of the corporations I work for. That being said, give you a little welcome to CornCon. One thing, as being one of the people that run CornCon, we want you to support CornCon. If you could buy some merch, that'd be awesome. And then a little bit more about me. Like I said, my name is Shaun. I'm a very old school Linux admin. Kind of went through all the transitions of physical to hybrid to cloud to software as a service type of solution. And this talk here is mainly focused on a software type of solution infrastructure, essentially, not where you're just getting basically everything from a no host perspective. So in this presentation, I'm going to quickly go over the NTR application, the 3 layers and some of the common products. Then I'm going to go over what I consider a software as a service infrastructure and what I consider for this talk to be one. And then I'm going to go over some basic automation concepts. And then we'll finish up with some Q&A. Since there's no audience feedback and I'm doing this virtually for the first time, it's kind of interesting. So I'm just going to keep on talking and go through. So first we have NTR Applications. It's a standard 3-layer approach. We have a presentation, an application logic, also called service logic or business logic, and a data layer. The presentation layer is essentially your user interface. It's your web server. It's the thing that serves out the final content to your thing, Apache, Nginx, IIS, CloudFront. You have your application logic layer. This is probably the most interesting of layers because it can kind of be like a multi-layer layer, depending. But it's supposed to provide and coordinate the operation of the business logic for the presentation layer. So it's supposed to do all the in-betweens. It should only have temporary data only, so local file system, Redis as a cache, not as a database, Memcache as a cache. It can have an app, an API layer where you have Tomcat, JBoss, and WebSphere and API gateway. You can also have other services that like message queuing or anything else. Anything in that middle layer that you need to handle and manage and finesse your data on demand for that presentation layer. Like I said, this layer can sometimes be like 2 approaches. Sometimes you might have a logic layer that is private and a logic layer that is public, and that's where it almost becomes like 2 layers from a network perspective. And then finally, you have your data layer. Everyone should know, everyone's familiar with these. It's where your persistent data is stored. It's where all your data from your application lives. So, think relational, MySQL, MySQL, Express, Oracle, Postgres, Maria. And then you got your newer databases and NoSQLs and document DBs and whatnots like Mongo, Dynamo, and the rest. Then also another place where you have your data stores, S3 or SFTP or a Dropbox kind of scenario. So yeah, those are basically the 3 main layers. I'm going to cover what we consider software, I'm considering software as a service infrastructure in this meeting. So cloud service versus hosted service. What do I mean by hosted server for this presentation? It's basically a hosted server provided by a provider. So like EC2 is a hosted service, ECS, EKS, they're all virtual services. Also the same is true with like some of the database offerings that AWS offers and stuff like that. They help you set up and manage, but you still have hosts and physical infrastructure that, well, not physical, virtual infrastructure you have to manage and upgrade and maintain. So for cloud services, we mean something that's truly software as a service that you just throw in the cloud and it goes off. So ECS Fargate, EKS Fargate. RDS is this weird hybrid. Really shouldn't, because you do have to manage some layers, but it is just hosted in the cloud. And S3, DynamoDB is another great example of a hosted service, where literally you just have a ECS Fargate, you just throw a container in the cloud, you're not managing a cluster, you're not managing nodes, it can auto scale, auto go, and everything else like that. And we'll get more on that, but that's kind of what we mean for cloud service versus hosted service in this presentation. Even though it might have service in the name like ECS and EKS, it's not a full service that you can serve from without managing infrastructure. So the main categories I try to break it down into is maintenance, scaling, security, high availability, disaster recovery, and costs. Obviously with cloud services, there isn't none. It's one-time setup is more accurate, but there's no ongoing maintenance that you have to do. You don't do OS upgrades and patches and stuff like that. You have to plan out if you're deploying a new app, but the planning is quick and easy because you have no infrastructure managed. You're just deciding what load balancer you want it behind and that kind of stuff. Most cloud services by design scale. You don't have to do anything. Some of them you might have some tuning plans and stuff like that to make it scale differently for your workloads. But besides that, that's mainly one-time setup and you're done. Where hosted, you have to do auto planning. You know, if you're taking the ECS nodes, you can have auto increase and thing, or you might have to manually auto increase your nodes. You have to plan, and you're also spending money on infrastructure you're not being used. Whereas software as a service, sometimes it's more costly, but you're just getting what you pay for and you have nothing else to manage. Also, cloud services, they have limited access security by design compared to hosts, which has more access available. And this is just because of what it's running on. Like if you think about a host, you have all these other protocols, SSH for access and everything else like that. Or if you think of just a Docker in the cloud, it's just one port on your Docker container. There's no nodes or hosts behind it. But if you did Docker on ECS, you'd have your one port in your Docker container. You have all these hosts underneath it that have SSH and root layer access. It's just more access available to an attacker getting to your app or through your network. And also security groups, which will go into an AWS security group design with a security group by security group relationship can really secure your infrastructure really well. Next, high availability downtime in the cloud services. I call it the not it scenario. You know, it's the same thing when you got enterprise services for your Linux distribution. You know, it's not it when it fails. Because it's a cloud service, it's software as a service. If the service goes down, I mean, yes, your app's down, but it's not, you're not running around going crazy. And hosted, even if your cloud service, you still have to do usually some finessing and massaging to get your infrastructure back up. And you're it, you know, you got to make sure your instances come back up and everything else. Disaster recover in cloud services almost always have auto failover and backup design. Most of them are also in multiple availability zones, if not global. And then for hosted services, failover and backups all manual. They can be automated with auto scaling groups and stuff like that, but it's all a lot more manual setup. Where the cloud services, like I said, it's just kind of by design. You do a couple clicks and you're done. The software as a service usually does cost more for hosting, but considering all the maintenance and all the rest of the stuff you don't have to worry about, I personally think it's a negated cost by far. You're not worrying about OS upgrades, software, development life cycles for your packages and your repos and stuff like that. You're just worrying about your app and that's it. And the ECS, EKS, you're just updating your Docker container to the latest version and you got all your security packages and you're good to go. So the next thing, I kind of talked about most of these, but maintenance, like I said, it's cloud OS upgrades, patches fixed automatically, no downtime or resource planning needed for most cloud services. And for hosted, complete opposite. You got to do all that. You got to have planned downtime or temporary resource switch over. So while this one's down, this one's running and kind of plan that out. Same with scaling, most of those service design, one-time setup rules, and the complete opposite for auto scaling groups and etc. Cloud services, the security. One thing I do want to cover is one of my favorite things about AWS is the security group to security group relationship. So when you have a load balancer and a target end, you can literally relate the two so that only those two things from that security group can talk. So you're not even working with IPs, you're talking of objects of security groups that define. With no host, you think there's, even if you put a host on your infrastructure, because it's not in the security group of the load API ALB or the RDS or your data instance, it's not going to get access to anything. And again, the host server is your responsibility. High availability downtime. AWS services, most of them provide at least 4 nines or better. And like I said, it's offered by design for multiple availability zone, if not global. Hosted servers, you kind of have to determine your own. Obviously, if you're using some of their servers like ECS and EKS, you got a little bit of reliability on the nodes, but if the Docker server something fails, it's still kind of up to you to bring it back up. And then disaster recovery, same kind of thing. AWS offers snapshots, backups, and versioning for data recovery for most services. And that's also true even for some of the manual ones as well. But most of the time, all that stuff in a hosted scenario, you're doing manually. And then, like I said, they're either global or multiple zone. And we were talking about the cost, paying the service and cost more than the instance. But it usually said you're not dealing with any infrastructure, no hosts, no maintenance. The costs kind of outweigh themselves in my own time. So I'm going to cover AWS services for our application or an application that you can use that will just leverage full web services and you don't have to have any hosts in the different styles. So not all services meet all enterprise needs for a software as a service solution. These are the questions you should ask for your AWS service revolution. Do they scale the way you need them to? Like RDS can't horizontally scale, so you got to make sure you're aware of that. And when you do your vertical scaling, you have downtime and read only, and make sure you know there's a limit. Do they have multi-AZ options for high availability? Does it have health checks and auto recovery for high availability? Do they have snapshots, backup, restore functions for disaster recover? Do they have security by design and can it be locked down? And is this service automatable with CloudFormation or another Terraform or whatever you'd like to use? So here's some recommended services that kind of meet most of these things. Provided by AWS, and they meet these needs. Using a presentation layer with S3 and a CloudFront for your CDN is a fantastic solution. S3 has everything you need for an enterprise solution, and CloudFront is a great CDN. Then you have ECS and EKS Fargate. Those, like I said, are not ECS or EKS. They're just deploying the cloud container services. And then if you needed, you had web apps and stuff that are presentation layer. And the same thing with logic layer, you can kind of do that. And there's Lambda API gateways coming out as a very popular way to make API layers. Then you get your data layer. I put RDS in there just because it's so thing. It's not truly software as a service because of its scalability and stuff like that and has some limitations, but it's so popular. But NoSQL databases like Dynamo and stuff truly get you this true software as a service. You got S3 for storing data, and then they even have the SFTP or the transfer service for your thing. And then the stuff that kind of makes it all kind of happen in the back end is the application load balancers, the CloudMaps, the Route 53s, and AWS is kind of proprietary target groups and weights and stuff like that that interact with all this for the auto scaling and stuff like that to work. So the first I said is S3 CloudFront. There's no host to manage. It does everything for you. CloudFront provides CDN for load. If you're using NPM, there's even great NPM modules that will auto deploy just the changes of your static content to S3 and only recache the CloudFront entries for those entries as well. So you're really just deploying only the new and not, uncaching a bunch of other stuff. There's no hosts in this. It's only static content. So once you set up your S3, if it's public, it's probably going to be global anyways, and public anyways, and therefore, you don't have many rules. And then you got full versioning backup and data recovery. So it's kind of set up once, build a CI/CD pipeline for when you're done. ECS Fargate, kind of similar thing. You have, basically Docker service on demand, just goes right in. Full disaster recovery, no host to manage. This has a cool thing with AWS CloudMap and Route 53, where you can have an internal host private domain, and they use service. It used to be called service name discovery. Now it's their CloudMap, and basically the instances in your ECS. So you deploy a container, you want 10 replicas to start with, and it can build on load. It'll auto add the 10 replicas into a Route 53 private DNS entry, and that's so you can access internally. At the same thing, it'll also put it in a target group, and that's how the application load balancer knows to auto scale to those instances as those instances come up. It's kind of one of the magics of ECS and EKS Fargate. One thing here, I always say no stateful data to back up, and I still don't believe it should be there. But ECS and EKS Fargate a couple months ago did release stateful data features for EFS and EBS. So if you did need stateful data or had volumes that you need to accomplish, it can be done, but it's still, I wouldn't recommend it as a design practice if it can be avoided. The next Lambda API, it's very similar to ALB for Lambda. You kind of set it up, you point your Lambda functions, you put your API gateways to it, and you're good. Again, there's no host to manage, you just publish your code and run. Scales on load by request in your Lambda functions, and you have nothing. There's not even host infiltrate. They can infiltrate your scripts, but then they have no footprint from that point forward. And then high availability and downtime is kind of all handled by AWS. Next is RDS. Everyone probably knows this the most from AWS, one of their first big wins with software as a service like products. There's no host to manage in this. You do to manage your databases, you have to upgrade them, you do have to do a little bit of stuff, but most of it's one-time setup. The ability for read-only replicas. One of the biggest things I find is the scaling of vertical limits. You're gonna eventually hit that cap and there's nothing you can kind of do. Where NoSQL and newer databases have vertical scaling, horizontal scaling, and don't have that issue. Security, again, no host, no in footprint. And again, it handles all high availability downtime once you have a couple replicas and a read-only replica. You can do global deployments. They've done a lot of stuff with RDS. They have serverless that auto scales and stuff like that, depending on your need. And again, it can all be done CloudFormation, has backups, and this particular feature has point-in-time recovery as well. Then you got NoSQL and others. I wouldn't consider all of them the same. Not all of them meet these offerings. So like the two main ones that I would say for this are DynamoDB and Cassandra come closest to meeting the software as a service maintains, where Dynamo, you just create a table in the cloud and you're done. All the rest are more managed hosts, kind of the RDS model. But since the RDS model is popular, I still thought it was mentioning. So because of that, the managed service ones need a little more maintenance versus the ones that are kind of like Dynamo, you just throw in the cloud. Most of them can auto scale by load. Some require manual horizontal scaling, but most can do it. The service ones just auto scale. They do have smaller footprints. They are kind of hostless. You don't have access to the host. It's just a service. And you do security groups and all the other fun stuff from AWS. Most of them can all be done with AZs, regions, Redo. Dynamo is global in some cases, and then you get disaster recovery. Finally, SFTP, it's probably just an easy transfer service. It's basically just an SFTP server in the cloud. It can be identity provider integrated or not. And then you auto scale by default. You have no hosts again, so it's just a global footprint. It can be within your VPC too if you want internal SFTP for data transfer between layers and stuff like that. And the best part, and they now have full FIPS support for the compliant people, for the regulatory. You can get full FIPS support on your S3 bucket for the SFTP service that backs it. And again, it uses S3, so you get all the high availability features and uptime of S3. So the network infrastructure, I think I already talked about the CloudMap and the Route 53. That's kind of the glue that kind of holds a lot of the newer software as a service deployed infrastructure together. It's definitely what holds ECS and EKS together, especially when you do private and public clusters. Private cluster can have one hosted zone, other one can have another hosted zone. The replicas get automatically added to the Route 53 record, and they automatically get thrown over to the application load balancer target group all through the CloudMap and Route 53 integration. API gateway and all the other fun stuff. And most of this is all network infrastructure as a service, if you will, by AWS. So you got all the high availability. You kind of set it up once, right? Besides, having internet gateway limits or something like that, you're pretty much just set up once and everything goes. It can all be done in a CloudFormation template. And of course, it's just a no data layer, obviously. Finally, I want to cover some automation, how people automate. At the end of this, I have a little demo that people can take online and go. But I probably wouldn't be the exact demo I would do. My favorite is Jenkins, but I'm just going to cover the concepts of automation and let you guys kind of, learn on your own and discover. So there's basically two parts of automation: continuous integration and continuous deployment. Continuous integration is really the ability to build, scan, test, and publish your code. So it has three basic build steps. Four basic steps. A build step where you compile your code. That can be it should be nvn install, not nvn. Sorry about the typo. npm install. You can scan your code with SonarQube on GitHub, and you can have different things. Some people just scan. Most companies just scan for results. Some people scan, send the results, wait for the analysis to be done, and then have blocking actions in the continuous integration. Like if you increase my security footprint, I don't want your commit to go through. You have to go back and fix your code. Then it should do all testing phases possible without your code deployed to a real environment, unit, functional, whatever you got. If you have mock databases and whatnot, that should all be done. And then finally, publish your code artifact. So that would be the Artifactory Nexus. Also, if your artifact repository has scanning capabilities, you can even do that same thing with Artifactory X-ray and stuff, where you can have a block in action or just make sure you're making sure the scan commits. And then you have continuous deployment. This is the ability to automatically build and publish your deployment artifact and deploy it to your infrastructure. So build here, I mean the actual deployment artifact. So you take your actual application and you do a Docker build. It becomes a little, less relevant to Angular because you built it. That is, your FOD files are your deployment artifact that you'd push to S3. But if you're, building an app like a Java app or something, your Docker build would actually be what I would consider your deployment artifact in this scenario. And then you publish your deployment artifact. Like I said, if it's Docker, you push your container registry. If it's S3 files, you push it to the S3 file version bucket for the artifact retention or to deploy it. And then finally, you do some switch up. Like I said, the ECS Fargate, it's just a simple force update, and it grabs the newest image from your task definition. There's nothing else to do that. It has great auto load balancing handling over. The way it works is once you send it to do an update service, it starts a new one and pulls the newest image. And once it pulls the image, it boots it up, makes sure it passes the health check. Once it passes the health check, it puts it behind the application load balancer. The application load balancer then waits for the old ones to finish their requests and then takes them out of the application load balancer. You have a flawless upgrade with no downtime as long as your code works. And then finally, S3, it's simply to upload new content to a public bucket and inform CD and invalidate old. There's I should say NPM, sorry for the spelling error again, but there's like 3 or 4 great NPM modules out there that you can look up. They all kind of do S3 and CD invalidation based on your build of your static code. So it kind of makes it just seamless, and you're only targeting the paths and files change rather than, maybe doing a whole directory or whatnot. And then finally, like I said, because my time is about up, try it out. I was about to go make this whole entire thing, and I had a cloud formation I was going to use and do a GitHub, and I went Googling for an app online, and I found this great AWS getting started hands-on building a modern app. It pretty much has everything I talked about for the most part, using all software as a service. With a little twist. They do have a couple extra services, and they're actually using CI/CD in AWS, which is kind of cool. Like I said, I'm more of a Jenkins guy, and I do autoscaling groups, stuff like that. But this is kind of their thing. The only thing that they don't do that I kind of covered is they didn't put CloudFront in front of their S3 buckets that are doing the presentation layer. But besides that, it pretty much has everything I covered in a few extra little things. But this will build you a no-host infrastructure and show you a demo app of it. So if anyone that wants to learn more, please try it out. Finally, any Q&A, I will be on Discord. My username is World Scavenger, and I'll be happy to talk to anyone. Anyone wants to ask how I make Jenkins pretty solid in AWS and almost no hosty as well, please let me know. And thank you for your time. Enjoy CornCon, and again, please buy some merch. And I have to go back to the Rebel base because I help run this show. Have a good one and take care. I'm done.
All right.
I only got 30 minutes. I did my 30 minutes. I'm on time.
I'm going to mute you.
I muted myself.
Okay. Thank you, Shaun, for your presentation. I don't see any questions left in the Q&A. Hopefully everything worked well on your end. We're building as we go on our end. So hang tight for track. The second panel starts at 9:30 for track 2. Thank you.